Welcome to Prince Maths Clinic, the e-learning solution at your pace and time. Welcome once again to class. Today we shall be looking at a very interesting exponential equation that involves trigonometry. And here we have that 256 to the power of sine square x plus 256 to the power of cos square x equal to 68. Let's find the value for s that will satisfy this equation. First of all, write out the question. That's the first thing to do. 256 can be written as 4 to the power of 4. Because 4 to the power of 4 means 4 times 4 times 4 times 4. It will give us 256. Then, remember, it's carrying the power of sine square x. Plus, this is also another 4 to the power of 4 times cosine square x. All equal to 68. Now, we can multiply these two powers together in indices. If you have a to the power of m, then another power n as well, it means that multiply the two powers together, which becomes a to the power of m times n. So we are free to multiply these two powers together in this instance. So it gives me 4 to the power of 4 sine squared x plus 4 to the power of 4 cos squared x, all equal to 68. Now I want all the terms in the power to have either cos square x or sine square x. But how do I do that? From trig identity, we know that sine square x plus cos square x is always equal to 1. So I want to make cos square x here the subject. Therefore, my cos square x will now become 1 minus sine square x. Anywhere you see cos square x, you can fix in what? 1 minus sine square x. Or you can say sine square x is equals to 1 minus cos square x. Such that anywhere you see sine square x, you can put 1 minus cos square x. But since I've chosen to say cos square x equals to 1 minus sine square x, I'm going to put 1 minus sine square x to replace cos square x here. Therefore, I will have my 4 to the power of 4 sine square x plus 4 to the power of 4. Then instead of cos square x, I'm going to put 1 minus sine square x equal to 68. Now, I want to expand the power here. So this becomes 4 to the power of 4 sine square x plus 4 to the power of 4 times 1 is 4, then minus, then 4 times sine square is 4 sine square x, all equal to 68. What's the next thing to do? We know that from the laws of indices, if I have a to the power of x minus y, it can be written as a to the power of x divided by a to the power of y. Because the two have the same base, you can subtract the power in the denominator from the power in the numerator. That's exactly what happened here. And you can apply that rule here. Therefore, we have that 4 times 4 sine square x plus 4 to the power of 4 divided by 4 to the power of 4 sine square x. such that if you now look at similar what base, you can subtract their powers, all equal to what? 68. Then at this point, you can write this as 4 to the power of 4 sine square x plus 4 to the power of 4 is the same as 256. Remember, right? So 256, everything over 4 to the power of 4 sine square x, all equal to 68. Anytime you are dealing with an exponential equation, now you come to a stage where you can find some things that are similar, right? And you can no longer simplify any further. Always use what? Replacement. So I found that 4 sine square x is here, 4 sine square x is here. Now I can say that let p be equals to 4 to the power of 4 sine square x. So everything 4 to the power of 4 sine square x will now be replaced with p. So what do I have? So all of this means p, then plus 256 over everything here means p equal to 68. Now, in order to take off this denominator that I have here as p, I want to multiply all the terms by p. So if I multiply p by p, I will have p squared. If I multiply 256 over p by p, I will have 256. Then if I multiply 68 by p, I will have 68p. Here we have a quadratic equation. So I'll move 68p to this point. So it becomes p squared minus 68p plus 256 equal to 0. Remember, I've taught on this same channel how you can factorize quadratic equation in just a single step. So open two brackets equal to 0. Then put a p here, put a p here. We are going to look for two numbers that when we add them, we are going to get negative 68. And when we multiply them, we are going to get 256, positive 256. That number is just minus 4 and minus 64. So minus 4 plus minus 64 gives us minus 68. And if you multiply minus 4 times minus 64, you get 256. So from here, it means either of these is equal to 0. So it's either p minus 4 equal to 0 or p minus 64 equal to 0. Hence, p will now be equal to what? If you move it here, p will now be 4 or 64. But we have to recall that we have said let p equals to 4 to the power of 4 sine square x. We are asked to find x and not p. We will recall that our p is 4 to the power of 4 sine square x. Therefore, I want to substitute for p. This becomes 4 equals to now 4 to the power of 4 sine square x. So let's undo this part first. 4 is still the same thing as saying 4 raised to the power 1, right? Good. And we know from this law of indices that if we have a to the power of x equals to a to the power of z, since the bases are the same, we can say that the powers are equal. Hence, we can say that our 1 is equals to 4 sine squared x. From here, we can divide both sides by 4. Divided by 4. 4, we cancel 4. And we can say that our sine square x is equals to 1 over 4. In order to obtain a value for sine x, we have to take the square root of both sides. We have to take the square root of this side, and also we take the square root of this side. Therefore, you put a plus or minus here. Here, the square, we cancel the square root, so that our sine x will be equal to plus or minus the square root of 1, because this can be written as root 1 over root 4. And root 1 is 1 and root 4 is 2, right? So that becomes 1 over 2, right? Plus or minus 1 over 2. So, since x is plus or minus 1 over 2, x is either arc cosine plus or minus 1 over 2. And the only value that will give us arc sine of 0.5 is 30. So this is either plus or minus 30 degrees for x when we put p to be 4. We want to also put p to be 64. Put 64 in place of p, right? To get 64, I can say 4 to the power of 3, because 4 times 4 times 4 gives me 64. Then I repeat this. This is 4 sine square x. The bases are the same, therefore the powers becomes equal. So I can say 4 sine square x is equals to 3. So to take out this 4, I will divide both sides by 4. So 4 we cancel 4. Therefore I have my sine square x to be 3 over 4. So for me to have my sine x, this is as good as saying sine x times sine x. So therefore I have to take the square root of both sides. Now the square here cancels the square root, but before I do that, 3 over 4 is the same thing as 0.75. So I would do this, then replace this with 0.75. 0.75. So I have that my sine x is square root of 0.75. If you take the square root of 0.75, you will have 0.866. Then it means that my x will become what? The arc sine of 0.866. Punching your calculator, arc sine of 0.866 gives you what? 60 degrees. Now, because you have plus or minus, it means that this 60 degree can either be plus or minus. That positive 30 degrees, negative 30 degrees, positive 60 degrees, and minus 60 degrees. These are the possible values for x. So let me test one of the values back into the question. 256 sine square x. Sine square x means sine x times sine x plus 256. Then cos square x means cos x times cos x. Let's see if it will give us 68. Sine x is 0.5, because if you pick 30, sine 30 will give you what? 0.5. So if you multiply 0.5 by 0.5, you will get that to be 0.25. Then here you have 256. Cosine x. Cosine 30 right, will give you a particular value 0.8660. When you multiply it twice, you are going to get 0.75, such that by the time you now say 2 to the power of 0.25 plus 256 to the power of 0.75, you are going to get it to be what? 68. Also, if you pick negative 30 degrees, already negative times negative will give you positive. Then sine 30, of course, will give you sine 30. When you square it, will give you this. And cosine, minus times minus, will give you positive. Then it will also give you this, equal to that. So if you try the value for positive sine 60 and cosine 60, and as well negative. And let me see your answer in the comment section. I hope the video was helpful. Kindly share this video to your friends and colleagues. Bye for now.